Hello, this is Mrs. Repasky with a demonstration of the hydrolysis of salts. In the well plate, I have filled the 6 wells with distilled water and put in them universal indicator. They're fairly close to neutral, but not perfect. The indicator for the color key for this indicator is at the top of the screen. Hydrolysis indicates that some substances interact with water when they mix with water, not just that they get dispersed or they dissociate, but they also interact with the water molecules and thereby change the pH. Here's regular table salt, and just regular salt, and if I add a little bit of that to one of the wells, you notice that it dissolves, but it does not change the pH. And that's a normal dissociation. Sodium forms a strong base, sodium hydroxide, and the chloride ion would form a strong acid, hydrochloric acid, and neither of those would form in water. So they do not hydrolyze. The next substance I have is ammonium chloride. It has chloride, which is also in table salt. And it has ammonium NH4+. The chloride in the ammonium chloride is going to act the same way as the chloride did from the sodium chloride and not interact with the water molecules. But the ammonium does interact with the water. And you'll notice that the pH is very close to 4 because it's red. What happened was one of the hydrogen atoms, one of the hydrogen ions, came off of the ammonium ion and interacted with the water, producing hydronium. Hydronium is what's present in an acid, so the pH dropped. In the third well, I have just put sodium bisulfite. Sodium bisulfite's formula is NaHSO3. When there is a hydrogen on an ion, like bisulfite, HSO3 minus 1, you can't tell right away if a hydrogen's going to come off or a hydrogen's going to be added. So you interact it with an indicator, and by putting the salt into the water, I see that I get an acidic substance. The next substance I have is sodium sulfite, Na2SO3. Na2SO3. So the sodium, the Na, did not interact with the water, but the sulfite, SO3 minus 2, did. SO3 minus 2 gained a hydrogen, so it took a hydrogen from the water and produced OH ions, and that has a dark blue color. It is bluer than the green, so hopefully you can tell that. The next one I have is potassium carbonate, K2CO3. And this is a purple color. The one before is more blue. I can see the blue. Oftentimes with a hydrolysis lab, you're not exactly concerned with the exact pH that's going to form, just the type of interaction. Is the type of interaction going to produce an acid, or is it going to produce a base? The last example I have is sodium phosphate monobasic, and its formula is NaH2PO4. Out of the ions, sodium and dibasic phosphate, sodium is +1, and the other ion is H2PO4 -1. Which one do you think will interact? And do you think an acid or a base will form? Form your hypothesis or your guess, and I'll put some substance in. And this one formed an acid. So one of the hydrogens must have come off the H2PO4 -1 ion. Thank you for watching.